Hello dear students. In this video, we will be learning how to create a stack using linked list. In the previous video, we saw how to declare a node data structure. A node which actually is collection of integer data and pointer called next which points to another node. And also we declared a structure called stack which contains only one member which is a pointer called top. Although we didn't understand why this stack structure was created, I hope that you have understood why node is created, because that's the constituent of the stack which will store integer data as you see and a pointer called next. So although we have known why a node structure is declared, we are not aware of why stack is declared. All these things will be revealed in this particular video as we continue learning more about implementation of the stack. Now there are two major operations which we can perform on the data structure stack. First one is called push operation. Basically push means we are adding a new data in the stack, and the another operation is pop. Basically pop means we are removing a data from the stack. Just observe that if the stack is initially empty, let's consider that the stack is initially empty and we want to add 10 in the stack. Then we say we are pushing 10 in the stack. Now let's say that we want to push 20. That means we want to add 20. Then 20 will be pushed in the stack in such a way that 20 will have a pointer called next associated with it, and it will point to the node which stores 10. Hello, just check this, that 10 will also have next pointer associated with it, but next of this 10 will be null. And let's say now that we want to push one more value 30. In that case 30, the new value, will be pushed in such a way that 30 has a next pointer associated with it and next will point to 20. So that's the push operation, adding a new data in the stack. The second operation, which is pop operation, is removing a data from the stack. Remember, stack is last in, first out. So which was the data which we pushed last in the stack? 10? No, it was 30. 30 was pushed last in the stack. So if we are removing a value, that means if we are executing pop operation, then 30 will be removed first. Now if we again pop a value, if we are interested in removing a value, then 20 will be removed. And if we are again interested in removing a value, that is pop operation, then 10 will be removed. And after removing 10, the stack will be again empty. So these are the two major operations, push and pop, which are performed on the stack. It is but obvious that in this video we will see how to push a new value in the stack. And there is where we will see the importance of these two structures, the structure called node and structure called stack. Have a look at main. Here in the main program or in the main function, we have declared some variables like ch, x, z. Just ignore them right now. But very important line is this which I am pointing. Struct stack s. Now this is a simple variable declaration where s is declared as a stack. Then s will contain whatever stack contains, because s is a variable of type stack, and notice stack contains a pointer called top. So s is a variable which will contain a pointer called top. What have you done in this particular statement? We have created a new stack. Please try to understand. This S is a stack which has only one pointer called top. And currently, this top is not pointing anywhere because the stack is empty. Listen, we have not created any nodes which store some data where this top pointer can point. So basically, initially, when this particular stack is empty, there's nothing in the stack, then where should this pointer top point? This top should be null, indicating that as top is null, it means that this top pointer is not pointing to any node. By not pointing to any node, we mean that the stack is currently empty. That is the next line which has been written here. Check that we have written s dot top equal to null. Just have a look at that line. S dot top equal to null. So S has a member called top and its top is null. This line, this line is known as initialization of the stack. By initialization of the stack, we say that we want to tell that initially the stack is empty. How do you tell that the stack is empty? You tell that the stack is empty by saying its top pointer is not pointing anywhere. It means there are absolutely no nodes yet created in the stack. That's the beginning. Now, these two lines, struct stack S and S dot top equal to null are so important, declaring a stack and initializing it. Isn't it so? Like in the future videos, we will be learning about queues. So we will have a line in the main called struct queue, something like this. And then this queue will be a variable, okay, of type queue. Then this queue will have two pointers, front and rear. Okay. And then we want to tell that this queue is empty. So we will be writing queue dot front equal to queue dot rear. Both queue dot front and queue dot rear are null. Are null. That means both these pointers, front is null and rear is also null. By making front and rear as null, we are saying that the queue is empty. This is the way how we will begin any data structure. You have to first create the data structure by making that variable of that type and initializing a few things. And now we can call push function. Basically, at the moment, we have S, which has a variable called top, and this top is initially null. Now our interest is that in the memory we want to create node. Yes, we want to create node which stores data and there is a pointer called next. So we really want to create a stack here. And who will take care of the stack? Yes, top will take care of the stack. Top is a pointer which is initially null, but as we go on pushing new values in the stack, this top will point to the latest value. Let's say we push one more value, then this top will point to the latest value. But hello, initially the stack is empty, isn't it? So after declaring the stack S, which has a variable called top, as it is of stack type, this variable top, which is a pointer, has been made null to indicate that stack is empty. I hope you have understood till this point. And now we will call the push operation where the push function has been defined here below. And in the next video, we will see how to push a new value in the given stack. Thank you very much.